So we did derivatives with difference quotients, and the process of using difference quotients to find derivatives would become quite cumbersome as the complexity of the function increases. So we have to have some sort of a rule, and that's what we are going to talk about. The simplest case is a polynomial function. So what is a polynomial function? A polynomial function from algebra is any function of the form an x raised n, an minus 1 times x raised n minus 1, all the way up to a1x plus some constant a0. So all of those a terms are numbers, and then we have x raised n minus 1, and so forth. So as an example, a linear function f of x equals 3x minus 2 is a polynomial. F of x equals x squared plus 2x plus 1 is a polynomial. So what is the rule to find the derivative of a polynomial? The rule is quite simple. If f of x is equal to x raised n, then f prime of x is equal to n times x raised n minus 1. In other words, you move the n from the power to the front and decrease the power by 1. So if we have multiple terms in sum, so this is a remark, the derivative is distributive. That is, if you have multiple terms in a polynomial, you take the derivative of each term individually. Okay, so that is for a polynomial. What is an exponential function? An exponential function is f of x equals e raised x. The derivative f prime of x is also e raised x. From a practical standpoint, if you think about it, derivative is rate of change. Specifically speaking, it's instantaneous rate of change. And if someone asked you, well, how is an exponential function changing at any given instant? Naturally, the answer would be, well, it is changing exponentially, which is why the derivative of e raised x is e raised x. Extending that idea, suppose c is a constant. What is the derivative of f of x equals c. Think about it again. So c is a constant. The question we are asking is how does a constant change at any given instant? Well, does a constant change? Absolutely not. So the derivative is 0. So the derivative of a constant is 0. So here is a simple problem. F of x is equal to x squared. We want to find the derivative. Always identify the independent variable. All the other terms are constants. So the independent variable here is x. If I call that y, I'm taking the derivative of y with respect to x. The n in the power is 2, so the rule suggests the derivative has to be 2 times x raised 2 minus 1, which is 2 times x raised 1. The answer is 2x, and that would be f prime of x. Here we want to find the derivative of 2 times e raised x plus 1. Now, f prime of x, if we have a number multiplied to a function, in this case an exponential function, the derivative doesn't affect that 2 as long as it is in product. So 2 remains as is. The derivative of e raised x is simply e raised x plus the derivative of 1 is a constant, so that would be 0. So in this case, the answer is 2 times e raised x. So if you want to explicitly write this, we're trying to find df over dx. So you take the derivative of the first term and the derivative of the second term. This is what I meant by things being distributive. In the sense you can distribute the derivative through to individual terms. So here is another case, the independent variable. Is x. So we take the derivative of each term. So the first term has a power of 2. So 2 comes to the front and x raised 2 minus 1. The second term has a power of 1. So 1 comes to the front, x raised 1 minus 1. And the last term is a constant, and the derivative of a constant is 0. So we have 2 times x raised 1 plus 1 times x raised 0, which is 2x plus 1. So here is a tricky problem. We're trying to find the derivative of u of t. So the independent variable is t. The dependent variable is u. So what we are trying to find is du over dt, or u prime, or u prime of t. They all mean one and the same. So 2 remains unaffected. The derivative of e raised t is e raised t. T has a power of 2, since we are taking the derivative with respect to t, 2 comes to the front, t raised 2 minus 1. 1 is a constant. The derivative of a constant is 0. So the answer is 2 e raised t plus 2t. 2 minus 1 is 1. So we have 2 e raised t plus 2t. If we pull the 2 out, we have e raised t plus t. And that would be the derivative in its simplified form. So in this problem, we have g of u, so the independent variable, is u, the dependent variable is g. What we're trying to find is dg over du, or g prime of u, or simply g prime. Now, you see that square root and you may say, oh, that is confusing. What should I do? Well, you could rewrite that square root of u as u raised 1/2. They are one and the same, and you have u squared. So now we could use the rule that we have. N here would be 1/2, n there would be 2. So 1/2 comes to the front, u raised 1/2 minus 1. In the second term, 2 comes to the front, u raised 2 minus 1. So 1/2, u raised 1/2 minus 1 is negative 1/2, plus 2, u raised 2 minus 1 is simply 1. If you want to get rid of the negativity there, you could move u raised negative 1/2 to the denominator. It becomes u raised positive 1/2 plus 2u. And if you still want to rewrite in a different way, well, I could write it as 2 u raised 1/2 plus 2u. If you want to write it in a radical notation, that would be 1 over 2 root u plus 2u. So here is an example. The independent variable is t. The dependent variable is f. We are trying to find df, the rate of change of f with respect to t. Specifically speaking, instantaneous rate of change of f with respect to t. And that is the same as f prime of t, or simply f prime. And you may say, well, we did the rule for polynomials or powers, and how do we go about doing this? These aren't polynomial functions, or this is not a polynomial function. You're absolutely correct. So we have to do a bit of algebra here. So we have 1 over t. So if we move the t to the numerator, we have t raised negative 1. In the second term, if we move the t squared to the numerator, we have t raised negative 2. In the third term, if we move e raised t to the numerator, we have 2 e raised negative t. So how do we take the derivative? So n here is negative 1, there it is negative 2. So negative 1 comes to the front, t raised negative 1, negative 1. Negative 2 comes to the front, t raised negative 2, negative 1, plus 2 times, side note, derivative of e raised negative t is negative e raised negative t. So we have negative e raised negative t, which would be negative t raised negative 2, negative 2 t raised negative 3, negative 2 e raised negative t. We have a negative in common. If we pull that out, we have t raised negative 2 plus 2 times t raised negative 3 plus 2 times e raised negative t. You can leave the answer as is, but if you want to write it the way it was in the question, removing negativity, we can move things to the denominator. T raised negative 2 is 1 over t squared. 2 times t raised negative 3 is 2 over t cubed. Last one is 2 over e raised t. So now we want to find the second derivative, which means we have to find the derivative twice. So here the independent variable is s, and the dependent variable is g, and we are trying to find g prime of s. So we have to rewrite the square root as s raised 1 over 2 plus 2. So 1/2 would come to the front, and we have s 1/2 minus 1. 2 is a constant. Derivative of a constant is 0. So that would equal to 1/2 s raised negative 1/2. You may leave it as is, or you could write it as 1 over 2 times s raised 1/2, which is the same as 1 over 2 times square root of s. We have to take g prime of s and take the derivative of this term again to get g double prime of s, which is the second derivative. So we have 1/2 already. The negative 1/2 is going to come to the front now. S raised negative 1/2 negative 1, which is negative 1 over 4. S raised negative 1/2 negative 1 is negative 3 over 2. You can leave it as is, or you could write it as negative 1 over 4 s raised 3 over 2. There are multiple ways to write s raised 3 over 2, but I am going to show you one way. I could write s raised 3 over 2 as s cubed raised 1 over 2, which would be negative 1 over 4 square root of s cubed. It depends on what WebAssign wants or what the exam is going to be, but either format is acceptable. Typically, we like to write it in this notation because it sort of looks nice. Here we want to find the derivative of, this has to be x. Derivative of f of x, and we have ax squared plus bx cubed plus c divided by x squared. And this looks nothing like what we've learned so far. So how do we do this problem? First thing to note, the independent variable is x, the dependent variable is f, so we are trying to find f prime of x. Since the common denominator is x squared, we could write it as ax squared over x squared plus bx cubed over x squared plus c over x squared. The x squares would go away, so we have a plus b, the x squared and the x cubed would get cancelled, we have bx plus c over x squared. From the previous problem, we can rewrite the last term as c times x raised negative 2. Here a, b and c are constants. Oh, this is not f prime of x, this is still f of x. I'm just rewriting the original function. Sorry. So how do we find f prime of x? The first term, a, is a constant, so that would be 0. The power here is 1, so b, 1 comes to the front, x raised 1 minus 1, plus c, negative 2 comes to the front, x raised negative 2 minus 1. So b times x raised 0 minus 2c times x raised minus 3. X raised 0 is 1, so we have b minus 2c. Move the x raised negative 3 to the denominator, we get x cubed. Here we have to find the second derivative of e raised x plus 2 plus e raised x plus 1 plus e. The independent variable is x, the dependent variable is y, and what we are trying to find is y prime first, then y double prime. Before we could do that, let's rewrite the function. E raised x plus 2, I could rewrite it as e raised x times e squared. E raised x plus 1, e raised x times e plus e. Mind you, e is a number 2.71828, and it keeps on going. So if e is a number, e squared is also a number. So in the first term, e squared would remain as is. The derivative of e raised x is e raised x. In the second term, e would remain as is. The derivative of e raised x is e raised x. E is a constant, so the derivative of that constant is 0. So we have e squared times e raised x plus e times e raised x. We have e raised x in common, so we have e raised x times e squared plus e. Now we want to find the second derivative. Well, if e is a constant, e squared is a constant, e plus e squared is a constant, so that entire term is a constant. It is some number. So we just have, number multiplied by e raised x. So when we take the second derivative, the number doesn't change because it is in product, and the derivative of e raised x is simply e raised x. So that is the second derivative. So the trick here is to do some algebra, rewrite the expression so that we can use the simple rules that we learned to find the derivative. here is a practical example. Biologists have proposed a cubic polynomial to model the length of an Alaskan rockfish at age A, and that is the length, where L is measured in inches and A in years. Calculate dl over dA. L is the dependent variable, which is the length. A is the independent variable, which is the age. So dl over dA is the rate or instantaneous rate of change of length L with respect to age A. So what is the derivative? Well, the first constant is 0.0155 and A has a power of 3. So 3 comes to the front, A raised 3 minus 1, plus the second constant, or minus 0.372. A has a power of 2, 2 comes to the front, A raised 2 minus 1, plus 3.95. A has a power of 1, so we have 1. A raised 1 minus 1. Last term is a constant. Derivative of a constant is 0. So we have three times that, which would be 0.0465 A squared. And minus 0.744 A plus 3.95 A raised 0 is simply 1. So the derivative is also a function. When we say dl over dA, A equals 12, means we have to plug in A equals 12 in the derivative. So if we use the calculator, I'm trying to type that in here quickly. I get an answer of 1.718. Let's just double check. So how would we interpret the answer? We know that dl over dA is simply the rate of change of the length with respect to h. So at 12 years of age, the instantaneous change in length of an Alaskan rockfish is 1.718 centimeters. And that would be the interpretation. And we are looking at the instantaneous rate of change. At the moment of age exactly equal to 12, what is, or how does the length change? In this case, it is 1.718 centimeters. So here is another practical example from a journal. The number of tree species in a given area A in the, how do we pronounce that, Paso Forest Reserve in Malaysia has been modeled by that function, where A is measured in square meters. We have to find S prime of 100. Here the independent variable is A, the dependent variable is S, and we have S of A equals 0.882, A raised 0.842. So ds over dA would simply be S prime of A, or simply S prime. The 0.882 doesn't change. The power here is 0.842. That is going to move to the front. The independent variable has a power of 0.842. Now it gets decreased by 1. So we have 0.882 times 0.842, which is 0.7426 times A raised 0.842 minus 1, which is negative 0.158. So S prime of A is that answer. Now we want to find S prime of 100. So 0.7426 times 100 raised 0.158. And I get 0.35872. So how do I interpret this? The instantaneous rate of change in the number of species S with respect to the area A at A equals 100 is 0.35872. So key things to remember: when we take the derivative, you've got to know what the dependent variable is, what the independent variable is. The derivative is always for the dependent variable, so the derivative of the dependent variable with respect to the independent variable. Derivative of a constant is 0. Derivative is the instantaneous rate of change. So we are going to move on to some interesting rules in differentiation, and these rules are important when we have two functions or more than two functions. As the name implies, the first rule is the product rule. So suppose we have two functions And we want to find the derivative of the product. Now, naturally, one might think, oh, let me just write this as, the derivative of f of x multiplied by the derivative of g of x. But this is not true. So we can't simply distribute the derivative like we would do with addition or subtraction. If we're adding a bunch of functions, or if functions are in addition or subtraction, then we could simply distribute the derivative and take the derivative of each function. But we can't do the same thing when we have a product. So we have a rule which is called the product rule. And I like to use a simpler notation. So I'm going to call the first function as u and the second function as v. So the derivative of the product of two functions is simply u times the derivative of v plus v times the derivative of u. So, as always, the derivative of v is d over dx of g of x. The derivative of the dependent variable with respect to the independent variable, and u prime is the derivative of the dependent variable, which is f of x in this case, with respect to the independent variable. And this simple rule is what we call the product rule. Now, what if we have multiple functions? So things get tricky. So if we have three functions, f of x, g of x, and h of x, first we've got to find the derivative of that. Using product rule, let's just call it p of x. Then we have to do the derivative of p of x times h of x using product rule again. So if you have multiple functions in product, then we've got to apply product rule multiple times, and things would get really out of hand. The next rule, naturally, is the quotient rule. Now, when do we use the quotient rule? Well, quotient simply means you have one function divided by another function. So, suppose we have two functions. So d over dx of f of x divided by g of x is equal. Naturally, one might think, oh, we'll just take the derivative of the numerator divided by the derivative of the denominator and we'll be done with it. But that is wrong. Life isn't that easy. So Once again, I like to use a simple notation. Call the numerator function as u, denominator function as v. So the derivative would simply equal to v u prime minus u v prime divided by v squared. That's v. And as always, u prime is the derivative of the dependent variable. In this case, it is f with respect to x. And the derivative of v prime is d over dx of g of x, which is dv over dx. So here we have a problem where we have two functions in product. So one is x squared plus 1, the other is x raised 5 minus 2. Of course, we can FOIL this and take the derivative, but anytime you have functions in product, it is advised that we use product rule. So I'm going to call that as u and that as v. So u is x squared plus 1, v is x raised 5 minus 2. U prime will then be the derivative of x squared, which is 2x. Derivative of 1 is 0. Derivative of x raised 5 is 5 times x raised 4. Derivative of negative 2 is 0. So the derivative of the function is given by the formula u v prime plus v u prime. That is the rule. So we have x squared plus 1 multiplied by v prime, which is 5 times x raised 4. V is x raised 5 minus 2. U prime is 2x. We have an x in common, so we could pull that x out, which would leave us with 5x cubed times x squared plus 1 plus 2 times x raised 5 minus 2. You don't have to FOIL this and make things complicated. You can leave it as is because it is in quite a compact form. Here we have two functions in product again. So that would be u and that would be v. So does it matter which one you call as u and which one you call as v? Well, it really doesn't matter when we do it with product rule. But you've got to be careful with quotient rule, which is why I like to just keep the numerator as u and the denominator as v, so that we don't have to mess with the formula. But with product rule, it doesn't matter. So u is square root of x, v is x squared minus x plus 1. I am going to rewrite square root of x as x raised 1 over 2. So u prime is 1 over 2, x raised 1 over 2 minus 1, which is 1 over 2 times x raised negative 1 over 2. We can move that x raised negative 1 over 2 to the denominator. It would become x raised positive 1 over 2, and I could write that as 1 over 2 times root x. V prime is the derivative of x squared, which is 2x. Derivative of negative x is negative 1. Derivative of 1 is 0. So f prime of x is u v prime plus v u prime. So u is square root of x, v prime is 2x minus 1, v is x squared minus x plus 1, and u prime is 1 over 2 times root x. Again, it's not necessary to simplify it further in this problem unless you believe that simplification is going to get rid of some terms and simplify it further more than what it is right now. It is best to leave it